So lesson number 9 continues on with function notation that we were looking at yesterday. So it looks at graphing a function. So it says, consider the function f of x equals 3x plus 1. The values of x are the inputs and they make up the domain, and f of x would represent the outputs and that makes up the range. In the previous lesson, y was our output and the range of the function. So really all we're doing is we're interchanging f of x and y. So if we have a function f of x equals 3x plus 1, we could actually change it into an xy notation and write it as y equals 3x plus 1. So you have function notation, which is f of x, and xy notation, which would be y equal. In both of these, the independent variables are the inputs and they're put on the horizontal. The dependent variables are my outputs and they are put on the vertical axis. Okay. So if we look at our first example, use a graphing calculator to sketch the graph of the function y equals 3x plus 1. What that means is I use my graphing calculator to sketch y equals 3x plus 1. So we take our calculator, turn it on, go to our y equals, and whatever is there we're going to clear because we don't need it. We're going to put in our new equation, 3x plus 1. And then we're going to graph it. We're going to use our standard window settings, so that would be a zoom and 6. And we check to see whether or not we can see the x and y intercepts. We can, although it's pretty squished. So what I might want to do is maybe change my windows. Instead of going up to 10, maybe I only go up to 5s. So -5 to +5, -5 to +5. And then graph. And now I've opened up that space a little bit more. So I can sketch this graph. There's the sketch of that graph. Probably not quite as, more like that. Okay? So if I look at question number 2. In each case, express the relation given in function notation as an equation in 2 variables. So if I want to take f of x equals 7x minus 23, and I want to write it as an equation in 2 variables, that means it's xy notation. So I replace f of x with a y, and I get 7x minus 23. If the equation is g of t equals t squared minus 2t plus 35, again, I replace the g of t with a y, equals t squared minus 2t plus 35. I can go backwards. If I have an equation that says y equals 11x minus 15, and I want to put that in function notation, instead of writing y equals, I write f of x equals 11x minus 15. The graph of the equation defined by f of x has an equation y equals 4 minus 3x. What would this equation be in function notation? Well, where I see a y, I replace it with f of x, and I get 4 minus 3x. Just a different way of expressing the same graph. The graph of the following function is shown. You cannot put this in your graphing calculator because it is not a nice equation. But we can use this graph to complete the following. Find f of 5. That means when x is equal to 5, what is the function equal to? So I go to 5, I follow it down, across, this would be -2. So I want you to do 2 and 3 on your own, and when you're done, you can resume play and see if you got them correct. So f of -2, when x equals -2, what does the function equal? The function equals 3. f at 4 when x is equal to 4. The function is at negative 1. Part B says write ordered pairs associated with each of these. X is equal to 5. Y is equal to negative 2. X would equal negative 2. Y would equal 3. X would equal 4. And y would equal negative 1. And those would be the 3 points that are on the equation. If I look at the next one, state the values of x if f of x equals negative 1. So this time I'm going backwards. If the function equals negative 1, that's looking along the y-axis. If the function equals negative 1, what will x equal? X will equal 4. So we would write x equals 4. If the function equals 3, x could equal negative 2, and x could equal positive 2, because I have 2 possible values for that output of 3. So I can write positive and negative 2. And if f of x equals 4, the same thing. My inputs, I have 2 of them. I can have a negative 1 and a positive 1. So D says use the notation in part A to make a statement about the points A and B on the graph. So point A has coordinates of what? Negative 5 and 1. So in function notation, I could write this as f of negative 5 equals 1. B has coordinates of 6 and negative 3. So the function notation of this one would be f at 6 is equal to negative 3. Part E says write the x and the y intercepts of the graph using function notation. So if I look at the x-intercept first, where does this graph cross the x-axis? It crosses the x-axis at 2 spots, here and here. So let's start off by writing out what the coordinates would be. This first one, the coordinates are negative 6 and 0. So function notation would be f at negative 6 equals 0. If I look at the next one, the next x-intercept is right here, which is at 3 and 0. So f at 3 would equal 0. Now, if we look at my y-intercept, in my y-intercept, I have 1, 0, and 5. So in function notation, this would be f at 0 equals 5. And the last step is to write down what our domain and our range are. So again, we need to remember that domain is our x values and range would be the y values, our outputs. So if I look at my input, this graph does not have arrows, which means it has a defined start point and end point. The graph starts here, so it starts at negative 6, and it goes to here, which would be positive 7. So I can write this as the set of x values such that negative 6 is less than or equal to x, or if I read it this way, x has to be greater than or equal to negative 6, but x also has to be less than or equal to 7. If I had used interval notation, it would be square brackets from negative 6 to positive 7. And the square brackets means that I would include negative 6 and positive 7. If I look at the range. Instead of a y, we now have f of x. That's the change in that one. But again, I have definitive starting and stopping points. So the smallest output that I have, or the smallest f of x value, is -4, all the way up to +5. So -4 to +5. And in interval notation, again, I would use the square brackets because it can equal. And this is what I would have for my range. So the biggest lesson, or the biggest understanding in this lesson, is just that I don't have to have my equations as a y equals. They could be an f of x equals. So the questions that I have for you to work on, 1b, 2b, question number 4, and question number 6, and question number 7, and then 10, 11, and 12.